Section 5.8 is on hyperbolic functions. This is our last lesson of Parkland's curriculum for calculus, and we're only going to hit a couple of these objectives. We're only hitting the part that Parkland wants us to. We are going to develop properties of hyperbolic functions, and we are going to differentiate hyperbolic functions. So the first thing I want to start with is, what is a hyperbolic function? A special class of exponential functions is called hyperbolic functions, and the name hyperbolic function arose from a comparison of the area of a semicircular region that's shown down here with the area of a region under a hyperbola. So think about this unit circle. A lot of times we use unit circle with trig functions, and we know that a unit circle gives a formula x squared plus y squared is equal to 1. 1 is our radius here. And if we wanted to go through and solve that for y, we can move the x squared over, take the square root. And let's say, for this example, we are only going to use the positive square root of 1 minus x squared. So we're not going to use the negative. This is what our graph would look like for the positive square root of 1 minus x squared. If we had the negative, we would obviously have a completed circle here. And now we're going to take a look at a hyperbola. And a hyperbola, we can basically do the same philosophy here. In this case, our a and our b are both 1. So we basically have this function negative x squared plus y squared is equal to 1. And if we go through and we solve for y, okay, so a and b are both 1. So we have y squared minus x squared equals 1. Okay, we're going to move the x squared over. Now that becomes positive. And then we end up with y is equal to the square root of 1 plus x squared. Now again, we're only looking at the positive part of the hyperbola. Okay, so we're only looking at this part. So a hyperbolic function is a function that basically uses that. It's kind of like similar to the unit circle. This would be considered our unit hyperbola. And we're only looking at the positive part. Okay, here are some definitions that you need to write down. These are definitions that you're definitely going to want to have on your index card for the exam next week and for your final exam. And basically, these first two are ones that you definitely need to know. We definitely will use these a lot. And if you notice here, the tangent ends up, all of these end up being basically using our trig functions or our knowledge of trig functions or our trig relations for this. So this is called the hyperbolic sine function of h, and that is going to be equivalent to e to the x minus e to the negative x over 2. The cosine of the hyperbolic cosine of x is going to be e to the x plus e to the negative x over 2. Tangent's hyperbolic function would be sine over cosine's hyperbolic function, and then so on and so forth. So go ahead and get these definitions down on your paper. Do notice that there is a restriction here in the domain where x cannot be equal to 0. So make sure you write that down. In your textbook, you have some graphs of hyperbolic functions. So this example right here, since the hyperbolic sine function of x is e to the x minus e to the negative x all over 2, we can separate that into two separate equations, or two separate terms. And then this is basically it's this graph. So if you go to your graphing calculator and you type this in for y1 and you graph it, this graph right here is actually what you're going to end up getting. So that would be the hyperbolic sine function. This one right here is going to be the hyperbolic cosine. This is the hyperbolic tangent. This would be the hyperbolic cosecant, hyperbolic secant of h, and then cotangent would be the hyperbolic. This is in your textbook. So there's an idea of what the graphs look like. Okay, we can basically use some of these identities to be able to go through and improve some of these. So many of the trig identities have corresponding hyperbolic identities. For example, if we start out with a hyperbolic cosine function that's being squared minus the sine hyperbolic function of x that's being squared, we basically can go through and do that substitution of our definition. So we already wrote that the hyperbolic cosine function was e to the x plus e to the negative x over 2. And since this is squared, we can go ahead and square that quantity as well. And then this is minus, and then this is just the definition of the hyperbolic sine function that also is being squared. We can go through and square this. Remember, you're squaring the numerator and the denominator. So we can go through and square both of those. Okay, and then in this case, we're going to square both of those as well. And if we go through and put them together, since they do have a common denominator, you're going to end up seeing that we have e to the 2x and then minus e to the 2x. We have a positive 2 and then a minus a negative 2. That's going to give me a positive 4. We have e to the negative 2x minus e to the negative 2x. Okay, so basically we end up getting 4 over 4, which is 1. So here's an identity. And I have, shortly after this, I'm going to show you a whole page of identities that you can write down. But here's proof, just going through a proof for an identity. Here in the second example, this is 2 times the hyperbolic sine function of x times the hyperbolic cosine function of x. So again, we're just substituting in those definitions. So it's going to be 2 times the sine hyperbolic function is this right here, times the hyperbolic cosine function of x, which is right here, and then we're just multiplying. Okay, so I know 2 times 2 is 4 in the denominator, but I have a 2 out here, so that becomes cancels, and I just get a 2 down here, and then I'm just going to go through and FOIL, multiply the first, the outer, the inner, and the last, and this is what we end up getting. And what you end up realizing is that this ends up being the hyperbolic sine function of 2x. So there's a couple of identities. On this next page, I'm going to give you a few minutes to go ahead and copy down. These are the hyperbolic identities. Okay, this is exactly why I told you that you are going to want to copy down all of this on index cards for your exam. There's no way anyone should have to memorize all of this, but you do need to be able to apply it if necessary.